Complex, i.e. fun. Radical equations. Okay, here we go. Look, Billy was given this radical equation to solve. Billy solved it incorrectly. This is like the new math, right? I never got this when I was a kid. His work is shown. Here's what Billy did. Did he do anything yet, or is that just the same question? Yeah, he just wrote it down, and he wrote it down correctly. Okay, so far so good. Okay, and then what did he do? Is this okay? Well, I'm seeing all sorts of this, and I'm seeing some of this, and well, what did he do? You remember those steps we saw yesterday? What was step one? Isolate the radical. And if you got two radicals, well, you probably want to isolate the ugliest one. Is that what he did here? Yeah, that's what he did. Because believe me, you don't want to FOIL this, do you? No. Yeah, I mean, it'll still work, but you don't want to do that. Trust me. Okay? So yes, this one looks uglier than that one. So I want this one by itself. He took that, threw it over there, and that's what we have. Okay? So yeah, that looks fine. And as an added bonus, they're all positive too. So that's always nice. Next step. Well, now you don't have any choice. You got to get rid of these radicals. So square that and that'll be gone. Whatever you do to one side, do to the other side. Okay, the brackets don't show up quite as well here. Hopefully they look better in your book. All right, so that's all good. And then you square this thing and you're just left with whatever's under the radical, okay? And then he did this here. Are we happy? And see, this is always a little tough. It's because some of you are really, really good learners. You see something, and it's almost photographic. That's why sometimes maybe it's not a good idea to show you his mistake. Maybe some of you will remember this and then do it. This is not correct, okay? Don't do that. What did he do wrong? Okay, so here we've got this equals 3 plus the square root of a plus 1. All right, I want to square both sides just like he did, which gives me 3a plus 4 is, but what's this? What should you do first? It's this thing, a plus 1, times itself. It's this thing squared. Okay? That is not a squared plus b squared. Okay? It's this thing times itself. So don't try to take a shortcut, which we all sometimes try to do. Write this out. Okay? I don't care if you can do that in your head. Trust me, it's worth the 10 seconds. Write it out and you won't make a mistake. Okay? So that is wrong. Game over. If this is a 2-mark question, I don't know, depends on my mood. He's got a half, maybe 1 out of 2. Okay? Probably a half out of 2. Rest, I don't care what else you do. It's all for naught because you made a mistake. Okay? So show the correct work. Don't be Billy. Do it properly. What do I do now? Well, can't do anything with that. But this, I'm going to FOIL properly. That 3 times 3 is 9. Plus, outside, this is confusing, so I'll write it all out. I'm not going to take a shortcut. Inside, 3 times root a plus 1 is 3 times root a plus 1. And last is, what is root a plus 1 times root a plus 1? Yeah, root a plus 1 squared, which is just a plus 1. Okay? So that's what I want to do next. And then what can I do now? I can collect these two guys. How many root a plus 1s do we have? I got 3 here. I got 3 here. That's 6 of them, right? And I got a 9 plus a 1. Let's make that a 10. And I got an A. That's all I'm going to do for this line. Okay? Then you might notice, well, I got some A's here, I've got some A's there, I can collect those together. I got a number there, I got a number there, I can collect those together. And I think what I did before was put everything to one side and then try to factor it. So let's do that. Let's minus 3a, let's minus 4. Okay, what do I got left on the left-hand side? Nothing. 0 is 10, take away 4 is 6, plus 6 root a plus 1. What is a minus 3a? Minus 2a. And then now what? Does that look like something we can factor? Like, does that kind of look like that? Like, do I have a squared term, an x term? No, it doesn't. So a little different procedure, okay? Let's backtrack a bit. What did we do first? I isolated a radical. Why? Because I don't like the radical. I want to square it and get rid of the radical. You're going to do the same step here. You don't like this. We don't know what to do with that. I can't solve that for a because there's a radical over it. So I want to isolate that guy and square it. We're going to do it twice in the same question, right? It's like 2 for 1. So actually, what I want to do is get these guys back to the other side, okay? So 2a minus 6 is, that's gone, that's gone. I want to put this guy by itself. So I can get rid of the radical, square it. Whatever you do to one side, do to the other side. Okay, so I've got 2a minus 6 times itself, again for the second time in this question. Okay, write it out. It's this thing times itself is, what do I got left on the right-hand side now? Does this exponent of 2 apply to that 6 as well as the radical? Yes. 6 squared is 36. And what is the square root of a plus 1 squared? A plus 1. Someone tell me what mistake I made. Yes, got to have brackets there. Okay? Okay. No more radicals. Yoo-hoo. 2a times 2a, 4a squared, minus 12a, that's minus 24a, negative 6 times negative 6 is 36, is, got rid of those brackets, let's get rid of these brackets, 36a plus 36. Finally, now we're back to some of the stuff we had 3 days ago now. Okay? I'm solving a quadratic. So what do I want to do? I want to collect all my stuff again. Let's minus 36 to both sides. Boom, those are gone. Let's collect my a's over here. I want this thing equal to 0, just like I tried to do before, but I had a radical. So 4a squared minus 24a minus 36a is minus 60a is 0. Don't forget the 0 part, because we're solving this. We want an equal sign. Now, how do I do that? Is that a difference of squares? Well, whether it is or whether it isn't, what should I always do first when I'm factoring? All right, is there a common factor between 4 and 60? Take it out. A squared and a, take an a out. 4a times a is 4a squared. 4a times 15 is 60a with a minus between them. That's not a difference of squares. But now, hopefully you can see what a needs to be for this thing to work. If a is what, I get 0 here. Yeah, if a is 0, I got 4 times 0, which is 0, times anything is 0, and this thing will work. Or if A is 15, this thing will work. Am I done? Good. You don't know yet. What's the word? These are roots, but one might be extraneous. Yes. One might be an extraneous root. Maybe both are extraneous roots, which means they don't really work. So we need to verify. Now, some of the kids in the other class were just pulling out their calculator and checking it. Obviously, on a quiz or a test, you need to show me this stuff, right? Okay? You can't just cross off one, because I don't know what you did to check it. So I need to verify. Go back to the original equation, plug in A, see if it works. So I'm going to check first. A is 0. I'm going to look at my book so I don't have to scroll back and forth. Square root of 3 times A plus 4 minus the square root of A plus 1, is that equal to 3? Does the left side equal the right side? This is the square root of 0 and 4, which is the square root of 4, minus the square root of 0 and 1, which is the square root of 1. And this says 2, take away 1. Is that 3? No, definitely not. 1 is not equal to 3. Nope. So what do we say? 0 is an extraneous root. You have to reject 0. Change colors. If A is 15, does that work? Let's find out. Square root of 3 times 15 plus 4 minus the square root of, if A is 15, plus 1, is that equal to 3? 45 and 4 is 49. Hey, I like taking the square root of 49. 15 and 1 is 16. I like taking the square root of that too. Oh, yep, thank you. 7 minus 4 is 3. 15 works. It's a real root. Okay? So that is the only answer. A is 15. Isn't that got some good stuff? Look at that. Okay, 1, 2, 3. That's it. Okay, like I said, none of that's on your quiz tomorrow, but you'll get one of them on the test. Pick your battles.